Hello everyone. In this video we will learn about the introduction of the application of integration to find out the area under any curve or between any two curves. In this particular video we will learn about the concept to find out the area, and also we will learn how to trace the curve, that is curve sketching. First we will learn about the concept of finding the area under any curve. Suppose we have a curve y equal to fx. We trace the curve and this is going along the x-axis or y-axis like this. Then we have to find out the area of this particular region, which is from x equal to a to x equal to b. Y equal to fx is the curve, and we have to find out the area from x is equal to a to x is equal to b. Above the x-axis, what we do? We can draw a strip of width dx here, or we can divide this particular interval from a to b in many small intervals. And then we find the area of this particular region by adding the area of all that particular intervals. That we have discussed in the videos for definite integrals, finding the area of the region by limits of the sum. So here what we are doing, we are drawing a strip of width dx, and dx is very small. If dx is very small, will you find that this is acting as a rectangle, the length of which is y? Then the area of this strip can be given by y into dx or not. And then to find out the total area of this particular region, we have to expand it from a to b. It means we will integrate this from a to b, and hence we can say area under the curve is equal to integral y into dx from a to b. In case the curve is like this, that is x is equal to f5. And suppose we have to find out the area from y equal to a to y equal to b. In such case, we can draw a strip parallel to x-axis, that of width dy. And then the length of this particular strip will be considered as x. This is very small, dy is very small, so we can say that this will also act as a rectangle. And if it is a rectangle, the area of this rectangle or area of the strip will be given by x into dy. Area of strip is equal to x into dy. Same way as we have done here, we will expand it from y equal to a to y equal to b, so that becomes the limits of the integral. And hence we can say the area of the region will be equal to integral from a to b x into dy. This is the only concept we are going to apply to find out the area of the region under the curve, maybe between the curves, by applying the integrals. According to the concept we have learned to find out the area applying the integrals, we have understood that the curve to be traced first. So we have to understand tracing the curve or about the sketching the curve first. Whatever the curve has been given to us, there are some specific curves which we are going to discuss in this particular chapter. They are, number one, we have straight lines. Number two, from the straight lines only we can make the triangles, so that is triangles. Number 3, we are going to discuss about circles. Number 4, we are going to discuss about the ellipse. Number 5, we have parabola. Generally, these are the only curves we are going to discuss in this particular chapter to find out the area. Now, first we talk about the straight line. We know the equations of the straight lines are generally given in the form ax plus by plus c equal to 0. Tracing or drawing a straight line on the graph. We have also learned in the previous classes, and also we have learned in the chapter or the videos based on the straight lines, and also in the linear equations. How to find out the solution of the linear equations or draw the graph of the linear equations in two variables. In such case, when the equation is given in two variables, to draw the line, what we do, either we take 3 points on the line or minimum 3 points on the line which are satisfying this particular equation, and we plot these on the graph, and then joining them we can find out the straight line. Or we can convert it into the intercept form. To convert into the intercept form, we can write it as ax plus by equal to minus c. Dividing it by minus c, we are getting x upon minus c upon a plus y upon minus c upon b equal to 1. Then we see here that minus c upon a is the x-intercept and minus c upon b is the y-intercept. We can plot these points on the x-axis and y-axis and join them to draw the line. That we have already understood. Like this, suppose this is the point that is minus c by a on the x-axis, and this is the point which is minus c by b, this is on the y-axis. Join them and we are able to draw the line. In case we have c equal to 0, the constant term is 0, then we know that the line passes through the origin. Then taking one of the point as the origin and any other point or more than one points which are satisfying the given equation can be taken, and we can draw the line passing through the origin. Now, after learning about drawing of the straight line when the equation is given, let's come to the triangle. In case of triangle, there may be two types of cases. One is that you have been given all the three vertices. They are A, B, C, and suppose the coordinates of that are x1, y1, x2, y2 and x3, y3. Then we can easily plot the points and join them to get the triangle. In case we are given the equations of the sides of the triangle, then either we can draw the lines directly and get the triangle, or we can solve the equations in pairs to get all the three vertices, and then that vertices can be drawn and the triangle can be obtained. Next is circle. In case of circle, we know there are three types of equations in the circle. Maybe standard equation, that is x square plus y square equal to a square, and we know in this case the origin is the center, or center lies at the origin, and the radius is a. We can easily draw the circle taking origin as the center and the radius as a. In case we are given the central equation x minus h square plus y minus k square equal to a square, we know that the center in this case is h comma k and the radius is a. Or we are given the general equation, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. Then we know that the center of the circle is minus g comma minus f, and the radius is given by root of g square plus f square minus c. Then plotting the center and taking the radius, we can easily draw the circle, or also we can find out the points where it is intersecting the x-axis or y-axis by putting y equal to 0 and x equal to 0 respectively. And then the circle can be drawn easily. The next curve may be parabola. In parabola, we have four types of equations, that is standard equations. In all the standard equations, we know that the vertex lies at the origin. The first one is y square is equal to 4ax, in which we know the positive side of the x-axis, that is the principal axis, origin is the vertex. Second is y square is equal to minus 4ax, in which the parabola comes to the negative side of the x-axis. Third is x square is equal to 4ay. In this we find that the focus goes onto the positive side of the y-axis. And hence this is the case we have. The fourth is x square is equal to minus 4y. Here the focus comes on the negative side of y-axis. So this is the parabola. In case we are given the general equation like y minus k square is equal to 4a into x minus h. That is y minus k whole square is equal to 4a into x minus h. Then the vertex lies at h comma k. And the axis is the x-axis. Then we find or plot the vertex first of all at h comma k, draw a line parallel to the x-axis, and then we can plot the parabola. Next we are coming to the ellipse. The standard equations of the ellipse are x square upon a square plus y square upon b square is equal to 1, or it may be y square upon a square plus x square upon b square is equal to 1. In both the cases we know that the center of the ellipse lies at the origin. In the first case, x square upon a square plus y square upon b square, the major axis lies on the x-axis, and hence this is the curve. In the second case, the major axis lies on the y-axis, and hence this is the position of the ellipse. Like this we can trace the curve first, and then after tracing the curves, maybe more than one curve, we have to find out which region is to be calculated for the area. And then after finding the region, we can apply the integral to find out the area of that particular region. In the next video, we will be discussing about the area under the curve above the x-axis, or maybe below the x-axis also. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.